Here's a little mini lecture for your geometry packet. It's this packet. I'm going to be talking about 11.2.3, which starts right here. Okay, you're supposed to learn about tangents and secants. I think we already talked about tangents in class. I'm going to do one of the problems with the tangents, even though I think you guys have already kind of explored that in class. And then I'm going to show you about the secant. Okay, so let's just do problem number 1. Problem number 1, I'm pretty sure that we talked about the fact that if you have a line and it's just barely touching a circle, it will always make a 90-degree angle with the radius of the circle. We did some explorations about that. So knowing that fact, that for all these problems in here, you're going to have a right triangle. So you're going to be able to use Pythagorean theorem. So it's pretty easy. There's your right triangle. So you know a squared plus, or leg squared plus leg squared is hypotenuse squared. Your hypotenuse is 30, so I just wrote it right here. 25 squared plus b squared is 30 squared. Did the math. I got b was root 275. Then it asked me for, it made it a little more interesting. It asked me for the area of the circle. So I know areas of circles are, you go pi r squared. And I know what r is. R is 275. So pi times, that's supposed to say 275, squared, or square root 275 squared. Here you can't read it. It's just 275 pi. And those would be square units. Like that. And you can check in your answer. There's some, let's check the answer, make sure that they didn't want a decimal for that. You can get a decimal for it if you want, but I just wrote it like that, or they just wrote it like that. Okay, so I'm going to be checking your work. I don't just want you to just write those answers down. I've worked out a lot of these problems. I know they require a lot of work to be shown. Number 14. I thought number 14 was pretty interesting. I already wrote it on it a little bit. I'll erase what I wrote. On these ones, you just have to kind of use a lot of different, kind of like a little puzzle. You're going to use a lot of different things that you already know in new ways. So you know how to do algebra. You have that AB is 2x minus 7 and CD is 5x minus 22. I know there are some of you who are just going to say, hey, those look like they're the same length, and you're going to set them equal to each other and solve for x, which really is what you're going to do, but I just kind of wanted to show you why, in case any of you are wondering why, how I, because things aren't drawn to scale. So I can prove that these triangles are equal because this is labeled x and x, right? So that means that these two sides are the same. These little hypotenuses that I drew right here, those are radii of a circle, so those are the same. So now I have hypotenuse leg. So that tells me that these two triangles are equal. That means this side and this side have to be equal by CPCTC. I can do the same exact argument over here with these triangles, and I have that these are equal. And so anyway, you don't have to do a proof on it or anything. I'm just telling you why you're allowed to set those equal to each other and solve for x. So I'm going to just write AB was 2x minus 7 and CD was 5x minus 22, and then you're just going to solve it. And then you're going to get that, and then divide by 3, x equals 5. Okay? So there's some problems like that. You're going to have to use a lot of different things that you know about triangles to be able to solve these. You have to be clever. Okay, on 21, it's 21. 21, there's a new kind of a formula that you don't know yet. It comes from the fact that we have these intercepted arcs. Remember, inscribed angles are 1/2 of the intercepted arc. I could do a little triangle proof on this and prove that to you, or you can read it in your book, and you should read the derivation of the formula, but just for today I'm going to actually show you the formula. It's right here in your packet. So when in your packet, if you have two, these are called secants, a line that goes right through the circle. If two secants of a circle cross inside the circle, you add the intercepted arcs. See, they added 60 and 40, and then you divide by 2, and that's going to give you this angle right there, the angle at which the two secants cross. Okay, that's just a little formula. It's supposed to kind of, I don't know, look in your math notes box, right? There's another little formula that says, it's kind of the same deal. Two secants of a circle cross outside the circle. That's the difference. This one they crossed inside and you had a plus sign. This one they're crossing outside, you have a minus sign. What you're going to do is take the intercepted arcs and do a subtraction. Subtract the small one from the big one, and then take half of it. So these are exactly the same, except for one has a plus sign. If they cross inside, there's a plus sign. If they cross outside, there's a minus sign. And when you do that, what you're getting is this angle right here, the angle at which the two secants intersect. Okay? And you can see they're saying OCA, OCA, right? So we're going to use that. We can remember that, right? You guys are young, you have good brains. 21. So I know that these are lines that are crossing outside of my circle. They're crossing on the outside. They're not making a cross inside. So I'm going to subtract the intercepted arcs. I'm going to go, the bigger one is x, so it's going to be x minus 80 is equal to 40. Actually, it's 1/2 of it, right? And that just came from on that opposite page that I just showed you. That's where that formula came from. So now I'm going to clear my fraction by multiplying both sides by 2, and I'll have x minus 80 equals 80. Oh. Okay, so x equals 160. And when I look at it, at first I thought it didn't look right because it was so big, but now I think I like it because when I look at it, it's this arc length right here. Right? That little arc length right there is 80. That looks like 160, so I'm pretty happy with my answer. I'm also going to do number 23 because that one has two secants and they're crossing on the inside of the circle. When they cross on the inside, you add the intercepted arcs and divide by 2, and that'll give you the angle where they intersect each other. So add these two up. That'll give me 84, and then divide by 2. What's half of 84? 42. And so that is what that's going to be 42, right? Because it's 1/2 of the sum of the arcs, right? It was 43 and 41. So we did all that. I think 42 is what I got. Let's look and check it. And I think we'll be out of time for this video. Let's check it. Number 23. Yep, 42.